Hello, everyone. Thank you for joining to my talk today about what happens when IoT meets serverless. Now, let's start me by introducing myself. My name is Pshul. I'm a software architect, consultant, lecturer. I've been working in the field for more than 9 years. You're welcome to talk to me about anything software, hardware, gadgety-related, gaming. If you have some pet photos that you would like to share, you're welcome to come. Now, today I'm working at a company called Code Value. We're a software consulting company, and Code Value is great. I really enjoy it there. We have a lot of really great professionals. And as any great company that attracts a lot of people to work there and a lot of clients, we have an issue, a very irritating issue. We almost don't have parking slots. You see, some people agree with me. They know it from personal experience. So as a software consulting company, we decided to approach this by creating some sort of a system that will allow our employees to know in advance if there is a parking slot available for them or not. So the idea of the system is pretty simple. We put a sensor on each parking slot, and when a car is coming, it sends a message to our server, and basically anyone can take out their app and see that there is one less available parking spot. So if we approach this in a more traditional way, we're going to see something like that. We're going to see some sensors that are connected to a load balancer, some device communicators, maybe a storage, probably some services that are going to run and compute everything and make decisions. But for a relatively small company like Code Value, especially for such a small app, this looks like too much. A lot of management and pretty costly. So we should remove everything and make it cheaper and more manageable, or at least not to manage it, at least. So we are going to move the traditional way to the cloud and use some serverless services on the way. So what is serverless? When we're talking about serverless, we're talking about saving time and money. Why? Basically, if we are going serverless, we're paying only for what we actually use. We're not paying for the service to exist. We don't worry about anything that's related to management on the server side. It's everything managed for us on the cloud itself. It's quicker to release because basically we're just adding more and more services once we want to add something as new functionality. And new functionality is just basically a new service in our serverless system. Now, we don't have to manage anything scaling related or load balancing. Everything is on the cloud. And we can focus only on actually writing the business logic and avoid any boilerplate. So if any one of you wrote an ASP.NET Core app, most of us did it in some sort of a way. We create our ASP.NET Core app, we open our previous app, and we copy-paste all the startup class. And also in serverless, we get the auto-scalability inherited in every service we're going to use today. So when to serverless, when we want to use it, if your logic can be disassembled into several small parts that can run independently, that's the case you're going to use it. If you have some irregular workloads, so for instance, if you're taking our parking app, if you don't have some workaholics as colleagues, probably at night no one is going to park in the parking lot, and the system is just going to sit there. Now, if it's hard for you to predict when the peak of your load is going to be, you're also probably would be better to use some serverless technologies, because it is going to scale as we go, as we need it, and scale down when we don't need it. And obviously, if you want to run closer to the user, it would be much easier to deploy something on a data center that is closer to your actual users. So if you're here in Kyiv and you have clients in the States, you would probably want to deploy it on a data server in the States and not here in Kyiv. But serverless is not always the option. Sometimes it's actually worse. So for instance, if latency is super critical for you, you probably want to run on-premise on the client side as it is and not introduce any cloud or any internet connection to the system at all. If you have a consistent, high and predictable workload, so if you know that your app is going to be running for half a day or 2/3 of the day constantly, probably serverless is going to be a bit more pricey for you and you would like something more dedicated. Now, if you have some long-running tasks that actually cannot be split into smaller modules, some services actually may not work at all and just won't be available for you as a solution. Obviously, if you have some complex computing with high memory and high CPU consumption, serverless is going to be very costly for you, and probably it's not a great option in that case. Now let's start talking about how we can migrate everything to the cloud and create a completely serverless system that's completely managed on Azure. So we start from computing. We're talking about something that's called functions as a service. The idea is very simple. It was introduced by DJ Wheeler back in 1952. He was talking about subroutines in programs. The whole idea is that you have some code that runs some logic. You don't really care how it runs, but you can rely on it. You can rely that this code will run and will execute exactly what you need. The whole idea is to be event-driven. So if something happens in our system, an event will raise and our code will be executed. Examples? If we are talking about Azure today, we're talking about Azure Functions. But if you're working on another cloud provider, if you're working on AWS, you got the Lambdas or the Google Cloud Functions, which is basically the equivalent in Google. So how do we create an Azure Function app? That's very easy, actually. Sorry, let's talk about Azure Functions first. So the events in Azure Functions are basically trigger-oriented. As we said about the events, the triggers are the name of the events in Azure Functions. We're going to use input and output bindings to match everything together. So an input binding is basically some information that your Azure function will receive, and an output binding is something that your function will return back, save to the storage, or pass the information on to another service on Azure. Everything there is heavily related on the dependency injection mechanism that is built inside the Azure Functions ecosystem. Now, we have an issue with cold starts. So if we have an Azure Function app that runs and no one uses it for a period of time, it will actually shut down to save for us some money. That results in a cold start environment where the first one to actually trigger a function will experience a delay in execution. Now, we can avoid it by, for instance, creating a time trigger, which will, every couple of minutes or so, run our function and keep the instance alive and running all the time, but we will pay for it. We will pay for actually executing those functions. But there are some other options. We can use a premium plan, which is costier, but it will make sure that you won't have any cold starts ever. Or you can go with app service plan. Basically, it gives the control to your hands, and you're the one who is going to manage the scale up and scale down, and you can decide when are you going to actually shut down the app completely and when to leave an instance or two alive. Now, we are going to talk about .NET today, obviously. But if you're working in any different language than .NET, there are many other languages that are supported. Probably you will find your favorite language here, and you can just go ahead and develop in your language. OK. So let's create an Azure Function app now. It's very easy. You basically fire up your Visual Studio, you use the template for Azure Functions and give it some name, created, and a new project is created. And it's a pretty small project. Basically, you have only 3 files here. You have the host JSON, which is basically gives you some information, some configuration you can do on the host that is going to run your Azure Functions. Later, you have the local settings JSON for environment variables and things like that, and your C# class. That's it. Now, inside your C# class, we're going to actually write the code. So an Azure function, it's basically just a method that you're going to write. And the only thing we actually need to make it an Azure function is just decorated with this attribute function name. We should give it a name, which should be unique to the function app itself. And that's it. We have an Azure function. But we need a way to trigger the function in some sort of way. So let's create a trigger based on an HTTP request. Now, we put it as a parameter inside our method, but we need to tell the Azure function somehow that that's our trigger. So we're going to use another attribute. You can find this attribute in the Microsoft Azure Web Jobs extensions HTTP. And basically, that tells the Azure function that this is our trigger, the HTTP trigger attribute. And after you're done setting up your Azure function, you add an iLogger. Now, I will not talk about it right now, but you will see it recurring during today's talk. You always add an iLogger. Always, always, always. It will save you a lot of headaches later on. So now let's implement our echo-func. We can get anything we want from the request. We can do something with that information. And then we can actually return a regular HTTP response. Okay, so here we are returning an OK object result. We put some information in it. But basically, that's it. Our Azure function is ready to use. Now, as we saw, it's very easy to actually create an Azure function. But if it's not going to be easy to deploy it, we're losing half of the battle. Luckily for us, deploying an Azure function is as easy as developing it. So you have the manual way, obviously. You can do it via Visual Studio, just publish to your Azure account. You can use an FTP channel to upload your files or upload a zip file of all your functions. And if you somehow want to do it in a continuous deployment, all the major platforms support pipelines that actually build and do everything for you. It's really something very quick to achieve. Okay, so we talked about Azure Functions as an HTTP request. So our client, our web app, can actually access it. But how about the other way around? Our system is large, and things are happening in the system. And we actually want to calculate something based on something that happens in the system. So for this, we're going to use the idea of events. Now, events, we want to process a high number of those each second. A lot of things are happening in the system every second. The idea behind this is to decouple all the components as much as possible. So components won't know each other, and we can replace them, upgrade them, and so on. We want to store and transform some events. And we want to integrate with other services as well. So it would be easier for us to make all the connections. So in Azure, we're going to use Event Hub. Event Hub is capable of processing millions and millions of events each second. It supports Apache Kafka clients. It integrates well with other Azure services. And again, if you're not using .NET, although we are going to see examples in it, you can use any of the supported languages. There are SDKs in many other languages you can use. It allows us to capture and store events in any way we want and need. And we have a very neat partitioning system which will allow us to actually handle those events in a parallel way. So it should look something like that. We have some event producers that sends events to our Event Hub. We have several partitions, several consumer groups, and each consumer group can create its own event receiver that will be connected to a different partition. Now, that's the idea. Now, how can we pass this event, after calculating it, back to the client? As we saw, we want to receive the information from the service and actually update our clients that there is one less parking spot available. For that, we need some sort of a communication service. So what do we want from our communication service? We want it to be real-time. We don't want to poll anything. We don't want to actually wait for messages. We want it to be bidirectional, so the client can update the service, and the service can update back the client. We want it to scale as we want, so if we have a lot of clients, we don't want to throttle any messages. And obviously, I don't want just anyone to connect to it, so we want it to be secure. So in Azure, we're going to use something that's called SignalR as a service. It's fully managed by Azure, which will allow us to basically just write the logic without taking care of the management part. It's cross-platform, so if you're not using .NET, again, you can use SignalR on your services and on your clients. It's easily integrated with Azure functions, and we're going to see an example now as everything just connects together. And it provides an abstraction over how it actually works. So for you, it's just send a message or receive a message. But behind the scenes, it will use WebSockets, and if anything goes wrong, it can fall back for long polling or server-sent events. Now, another neat feature that we have on SignalR service is sending messages either to all the users or select a group or a specific user and send them some messages only for them. Now, let's see an Azure function and how it can actually help us to achieve the whole way from the Event Hub and back to the client. So we're creating another function app, right? Another function, Azure function, that we're going to call it update users. Now, we need to introduce an Event Hub trigger this time because we want to react each time an event is actually passed to our Event Hub. To send the message later, we want to introduce an output binding for SignalR. As you can see here, we're using a different attribute, which is not a trigger one, and it receives a parameter of type iAsync collector of SignalR message. This is the messages we're going to actually send to our users. Now, you can find those attributes in those NuGet packages. Same initial namespace, Microsoft Azure Web Jobs extensions. You're going to see a lot of the triggers and bindings in this namespace. And obviously, as I said before, we're done configuring our method, our Azure function. Now we add an iLogger. That's a must. Again, I cannot emphasize it enough. Always add a logger. So we receive our message from our Event Hub. We process it in some way that we see fit. And then we create a message for SignalR message, and we add it to the async collector. Once we're out of the function, this async collector will flush all the messages to the SignalR service, and from there on, SignalR service is going to handle it for you and send all the messages to the connected clients. Okay, great. So we talked about almost everything now, but the talk is called When IoT Meets Serverless, right? So we need to talk about IoT and how it actually works. So I've been working on several projects already for different clients that had worked with IoT, and I saw a pattern. There are several things that clients that are not familiar with the whole Azure concept, making it all the time the same mistake. They're recreating the wheel of IoT. They're creating their own protocol on how to send messages and receive messages. They're creating their own secure way of communication, how to manage those devices, deployment. Everything they're creating again, although everything is already there. We have already all the tools on Azure. So what do we have on Azure? We're going to talk about IoT Hub today. It's just one of Microsoft's platform as a service solution for IoT systems. And it provides the infrastructure to work with the devices. Most of the work you're going to do is actually writing the code and defining the devices. You're not going to actually manage everything. It's all done for you on the cloud. And obviously, a lot of SDKs are supported. The IoT Hub exposes various endpoints for your use, for your needs, for your system events, and of course, integrates well with other services. Now, IoT Hub is divided into several tiers. We have the basic tier and the standard tier. They both are different in the price and in features. Each tier has several editions. Each edition basically allows you to send and receive more messages, but it's costier. So the basic tier is the cheaper one. It has some limited features, while the standard tier has all the features enabled, but it's costier, and the editions are equal on both. The fun part is the standard tier has a free edition. It has a limited throughput, but it has all the features enabled, and the whole idea is to run some POCs and to see if the IoT Hub actually suits your needs. But note that you can use only one IoT Hub per Azure subscription. Okay, so let's try to disassemble this wheel and see how IoT Hub actually answers all of our needs in this wheel. Let's start from top and work our way clockwise. Let's talk about device-to-cloud messages. So we want to send the device telemetry back to the cloud. We can use the SDK, obviously, or we can use directly the protocols that are pretty standard in the IoT world. We can use the connection string for the registered device to securely connect to the IoT Hub. And all the messages are stored on the IoT Hub up to 7 days, so we can refetch them and do some logging or checking what went wrong with it. And each message actually has a limited size, so pay attention for that. If you want to send a lot of data, you're going to be limited in that. Now, the frequency of how many messages I can send is the tier, the edition you selected on your tier on the IoT Hub. Okay, so let's write the device code now. We're going to use the Microsoft Azure Devices Client NuGet package, and you will see a pattern here. We create here a device client object, which is initialized by using the connection string of that specific device. Now, if you want to send a message, we need to create the object that's called message. Here, I initialize it with some object. I converted to JSON and just set the data. And then I only need to use the device client dot send event async, and that's it. Our message is sent to the IoT Hub and will be processed there based on what we actually configured. And that's it. That's everything we need to know how to send a device-to-cloud message. Now, how about the other way around? If we want to send the message from the cloud to our device. So here we have actually two options. Now, the first option is the easy one, the same message, but just the other way around. So it's not awaited. We cannot await actual response from it. It's stored on the device queue itself, and if we exceed the maximum queue size, we're going to have some errors in our system. The message can be rejected or abandoned unless you're using MQTT, which is a lighter protocol. And we can set a feedback, actually, some sort of an acknowledgement that we received the message and we processed it. Now, regarding the code, we're going to use the same NuGet package. And as I said before, we're going to initialize the same device client with the same connection string. Now, in this time, we're not going to create a message. We're going to receive it by calling the receive async method on the device client. Now, when this call returns, we're going to have the same message object as before. We can deserialize it back to an object that we know and just work with it. After we're done, We want to complete it to let know the IoT Hub that we're done working on the message. Now, this is the easy way, right? Just a message. But I said we have two ways of sending messages back to our client, to our devices. Okay, sorry, let's talk about the service itself first. So the service, we're going to initialize the service client, and we're going to initialize it with the connection string from the IoT Hub itself, okay, not the device connection string. And here we're going to see exactly the same as we saw before. We're going to create the message object and send it, but this time without the device client, but the service client. In this case, we need to send it to a specific device, so we're going to use a device ID and send there the exact message we want to send. Okay, so now let's move on to the second device, actually. To the second method, sorry. It's called direct methods, and the idea is a bit different. It's not just to send a message. The idea here is to actually initiate an action on the device. So it's not just letting the device know something, it's actually initiating something. We can receive an immediate response from the device. And this response will contain a status code and an actual payload that we can use to process this response. So, again, on the client side, we, again, initialize the same device client with the same connection string. This time, we're setting a method handler. We need to provide the method handler with a string. That string is uniquely identified between the two, between the client and the service. And we need to set some method to actually handle the request, conveniently named the same getData. So the handler is very easy to implement. You need to get the method request, some user context, and you must return a task of method response object. So basically, you have request, you have response, you get the information from the request, you build up your response, and you return it. Each time the service calls this getData method, you will get to that code and execute it. So on the service side, to send an actual direct method, it's pretty easy, almost the same as sending a regular message. So again, we're creating a service client with the IoT Hub connection string. Now, instead of creating the message object, we create the object cloud to device method. And pay attention, we're sending the same getData string inside. So this is the communication we have here. Now, we set some JSON as a payload, or we can use any other method. And we just send it, okay? This time we're using invoke device method async. Again, we pass the device ID and the method invocation object. And here we're actually awaiting an actual response from the device. Once we get the response, we can handle it, we can check the status, we can get the JSON from the payload and just work with it. Okay, so we handled all the messages back and forth. That's great. But how about managing the devices? I don't want to manage everything on my own. I'm using something ready. I want it to be able to manage everything. So IoT Hub provides us with several management tools. First of all, let's talk about Twin properties. We know that devices can have states, which version is deployed, when the device was installed. So we won't get any feedback on changing those properties unless we subscribe to the actual endpoint on the IoT Hub. Now, it's called Twin properties because we have two sets of properties. The first set is the desired properties, and these are the properties the cloud sends back to the device itself. It doesn't actually represent anything actual on the device, but the actual desire of our service to make a change on the device. So for instance, if our device is running in version 1 and we want to upgrade it to version 2, the service is going to send a change to the property, and the desired property of version will be changed to version 2. The device will catch that event And after the upgrade process, it will actually change the reported properties. Now, the reported properties is the actual property that the device is reporting back to the cloud, and these properties should actually represent the real state of the device. Now, we have properties and everything, but we want to know which devices have which properties. For that, we have the query capabilities of the IoT Hub. So all the devices can be queried. And an example of it, give me only the devices that were installed today. I want to see which one is malfunctioning. And we can query on the twin properties themselves. So we are not limited to only the built-in properties. We can actually create our own properties and query by them. Now, there are some built-in functions in the IoT Hub, in the query system, that we can use to actually level our jet even more. But the very basic example is, I'm sure everyone would know this form of select astrophy from devices, and it will just return everything. From there, we can just build on top of it and create some complex queries. Now, if we want to add a new device to our system, we don't want to log into Azure for each new device and register it on the IoT Hub. I just want to take a device, press a button so it would connect to the Wi-Fi, put it on the ground on the parking spot, and I just want it to work. So here comes the device provisioning service exactly for that. Now, the idea is that it should be a zero-touch provisioning. As I said, you just put a device and it should work. Now, you can route all the requests to a single IoT Hub, or you can do it with multi-tenancy or solution isolation. Really depends on your needs, but it's fully customizable and you can do whatever you need for your specific project. And the idea is pretty simple. So you have the device provisioning service in the middle, and once you introduce a new device that actually exists in the enrollment list, the device will connect to the provisioning service, and based on the logic, the device provisioning service will register the device in a specific IoT Hub instance. The hub will return the connection string and the initial twin properties back to the provisioning service, and it will initialize the device with all the initial staff. From there, the device provisioning service is out of the picture, and the device is talking directly to the IoT Hub. Okay, so now we know how to send messages and manage the devices, but how about security? I don't want anyone just to connect to my system. So for that, IoT Hub is actually supporting all the protocols that are pretty common in this field. So first of all the endpoints are based on access rights. Not anyone can access the endpoints, only the one who has the permissions for it. The devices are actually can be secured by X509 certificates, just the regular certificates. If you ever used one, you know how it should work, and it just supports it and works flawlessly. Now, the whole idea is the device is talking to a token service and receives a specific device scope token, which it is going to use to access in a secure way the IoT Hub from that moment. Okay, another very neat feature for the IoT Hub is message routing. We are talking about a lot of messaging in the system, and we want some sort of a way to actually route those messages around to different endpoints. So what I'm talking about is that we have a format, a common format across all the protocols. It doesn't matter how you send your messages, the format is going to be the same. And the route sends the messages to different endpoints based on the query you're actually creating for each message. If you have some duplicates, for instance, you send the same message from two different routes to the same endpoint, IoT Hub is smart enough to actually not raise the event twice. And various endpoints are supported. We are going to talk about those endpoints. But I strongly suggest you go and see if there are any other options that will be more suitable for your needs. So there is the built-in endpoint and the event hubs. Basically, the built-in one is an event hub. It's just built-in. And you can monitor all the messages using the Azure IoT Hub Toolkit extension that is available for Visual Studio or Visual Studio Code. But note that once you create any other route, this endpoint will stop receiving messages, and your only option to keep monitoring all the messages is to actually create another route that will send all the messages to the built-in endpoint. Obviously, we can create other event hubs and send everything there. Now, if we don't want to actually send everything to an event and want just to store it, we have the blob storage endpoint. Now here we will write batches of data that the batch is created by the size of the messages or by a time window. It supports the Avro format, so currently JSON is available as a preview and not everywhere. So when you decide which format you're going to use, pay attention. And for each batch of data, a new file will be created. So it's not a table, you cannot actually query it, but you can do some sort of going over files. Now, if you're using a service bus or queues or topics, pay attention that you need to set session and duplicate detection as disabled, otherwise nothing will work. Okay, your endpoints will be shown as unreachable, and you just won't be able to use it. Okay, nice. So we talked a lot about all the features, but how about deployment? I just want to try it now. I just want to create a device and write some code. So how am I going to do it? And this is probably going to be the shortest demo you're going to see on a talk. Just wanted to show you how easy it is. So here we are in Azure, and we are in an IoT Hub main tab. So to add a new device, all you have to do is go down to the IoT Devices tab. Let me move this around. And as you can see, now we have no devices at all. All I have to do is click the new button, create a name. So let's call it hello.netfest. As you can see here, I can set the authentication type if I want. For now, we'll skip it. And just click Save. That's it. Our device is already there, registered, and actually ready to use. If we go inside, we can see that we already have all the details for us, including the connection string that I showed you before. As I said, the shortest demo in a talk. Okay, so let's talk a bit about monitoring. Before we actually go and see the full example of how everything works together, let's talk for a minute about monitoring. Because the main problem here is actually debugging those remote services. It's hard, it's remote. I always hear people say to me that I don't like serverless because you can't debug it. And that's right, that's true. You cannot debug. It's very hard to achieve it. Now, especially the part where we're talking about a system that is divided into a lot of smaller parts. And actually following a message that the little device sends through all the routes, through all the services is very hard. The resources that we're using are scaled out and scaled in, and we don't even know which instance actually handled our message. Now, monitoring is the best approach in this case. This is what is going to actually give us all the information we need, and it's needed in any way. We should always monitor everything, so why not just level large it to a new, different level that will allow us to actually use it properly this time. So again, let's go to our Azure function. Logging is your friend. If you didn't understand my drift before, logging is a must in Azure Functions. You must use it always, unless you are going to regret it later. The iLogger object can be injected in any Azure function that you have. If you're using static functions, you can inject it inside the function itself. And if you're using just a regular class with regular methods. You can even inject it in the constructor itself. Now, application insights is the place to go where you want to look for your logs and see what messages were sent and what did you log everything. And if you ever used any logging mechanism, it should be very familiar for you. I remind you, this is our update users method. And everything we need to log is to actually use the logger we already injected, so you can log debug, log information, critical, exception, etc. And this will give you all information in the app insight later on. Okay, so now let's see a full demo, end-to-end, on how this system actually works. So, here we have a code that simulates a device. I don't have an actual device with me. It's in the parking lot. But we have here an actual simulation of a device. We should be able to take a spot or to leave a spot. Now here we have our functions. Now functions, it's just a regular Visual Studio project, so I can run it locally. It will create the host for me and just run it. That's just another instance. As I said before, we can scale out and scale in. So currently on my local machine, it's just another instance that is running. See, I have several messages that were stuck in the Event Hub. Now for the client, we are using something very simple, a regular Angular web app that all it does, it connects to the SignalR service and receives messages and shows if a parking spot is taken or not. Okay, so let's give it a minute to start up. And here we go. Okay, so let's see. Now we have here this little system. We have the device simulator, which is going to send the message back to the IoT hub. A routing will reroute the message to the appropriate event hub, which will trigger an Azure function based on the event hub trigger, which will send the message to the SignalR, and the client is connected to the same SignalR and will receive the message. But it won't work now. If now I will send a message from my device, it will fail because we didn't actually use the registered device. Now, remember the hello.NET Fest device I just registered? So here, if we're going to look at the connection string, the primary connection string, if we're going to copy it and actually use it in our code, so let's take down our simulator. Here we have this place for the connection string. I just pasted it. And if we run it again, now it should work and send the actual message from a device we just registered together on the hub. Okay, so if I send a message to take a new spot, it takes some time for the message to reroute. As I remind you, it's a cold start. So as you can see, all the message went through all the endpoints and took down one parking spot. If we leave a parking location, it just goes up again, going through all the route. Now, this is an Azure function, right? So we should be able to actually take it down, run it on the cloud, and it will be just another instance. I don't need to manage anything for it to work, right? So let's give it a try. I'm keeping my device simulation and my actual web client working and running. All I'm doing is going to our portal. I pre-deployed this Azure Function app in advance. It's the same code. And all I'm doing is starting the app again. Now, this is just another instance. All I need to do, let's give it a few seconds to actually start up. But basically, as you can see, I have the exact same setup with the exact same device simulator and the exact same client. And again, if no messages were stuck, let's see. Yeah, one message were stuck, as you saw it just triggered a bit. But we pressed simulate action of take spot, and the number went down. We can leave the parking spot again, and the number will go up. And now it's completely running on the cloud with just the edges working locally on my machine. Okay, so that's the end-to-end scenario. As you can see, we created a completely serverless environment that runs and manages a parking lot. Now let's summarize everything. We had this traditional architecture with a load balancer, some device communicators, a storage, some services. And we replaced everything that works exactly the same way, but on the cloud. Completely serverless. We didn't manage anything here. We just configured and developed the code itself. Now, if you are using any other cloud provider, you are going to have everything we talked about, more or less, with some changes, obviously. But we talked about Azure today, so that's just an example. Serverless is not always the option. It's great, and it saves money and time developing, but pay attention that if you have some limitations, it might not be the best case for you. As I said, we save money and time by using it. And IoT solutions are available as platform as a service on the cloud in every major platform, which you should use and not reinvent the wheel again. It will save you a lot of money and a lot of time just to use the service itself. And debugging is not easy, but it is possible. Always, always, always use log to monitor. If you need to take anything out of here today, it's to use logs when you use our functions. Thank you.
Okay, we have 5 minutes for questions.
Hi, Alex.
Hi.
Thank you for a great talk. Could you please share some insights about pricing and the overall solution cost using IoT Hub? Maybe some real-world numbers, examples.
Okay, I can actually share some real numbers. So we used, for a relatively small system, we used an IoT solution for a client, and we built it again with all the Event Hub and everything, and function and IoT Hub. We used the basic tier, which, if I'm not mistaken, costs $20 a month, something like that. And we didn't have too many messages in the system, and we ended up maybe about $30 per month for a system which is relatively small, about 50 devices, something like that, and just scales up and down as we need. And so yeah, if you have something small, $30 should be enough for you.
Okay, thank you.
Thank you for your talk. Could you tell about the storage in which you saved your data and about avoiding race conditions between writing of data?
Okay, so I'll tell you about different project.
Was it blob storage, actually?
Sorry?
Was it blob storage where
No.
you saved? No?
No. We actually didn't use a blob storage. We actually saved the data already processed. From the Azure function, you can create an output binding. You can use an output binding to actually use table storage and set everything in the table as rows, and you can later query it. So we didn't actually in our project use the blob storage. To actually avoid any race condition, you basically should actually save the events themselves. No event is going to change on the way. If you do want to somehow tackle, if you have some sort of citation, there is the E tag on each row which you can use and to know which row is which version.
So it was a kind of event sourcing in your system?
Yes, exactly.
Thank you.
Anybody else?
If your parking have 1,000 places, you are allowed to create 1,000 of devices. It is so painful if you do it manually.
Yes, it will be painful to actually configure each device. Probably in the making of the device, in the deploying of the code on the device, you can probably automate something. But to actually connect it to the system, you can use the device provisioning service and just connect it to the Wi-Fi and let it work. I hope it answers your question. Yeah? Okay, cool.
That's it, yeah? Okay,
Okay.
let's thank our speaker again.
Okay. Thank you.